Let's look at another example of how to apply the rational root theorem. So first what we want to do is list all possible roots. And so I would encourage you to pause the video for a minute and see if you can do this on your own rather than just watching me do it, knowing that the leading coefficient here is 4 and our constant is 9. So go ahead and pause this and write all of the possible roots. So all of the factors in the numerator are the factors of the constant term 9, which are 1, 9, or 3, right? So those are the factors in the numerator. And in the denominator are all of the factors of 4, which are 1, 4, or 2. So this gives us all of the possible ones. Now to find out which ones might actually be roots, we go to Desmos. And when I do that, I actually see that it looks like there's only 1 0, and it's happening at 0.5. Now it does have multiplicity, something even. Okay, so we're going to use that fact. So we know that f of x, since it has a root at x equals 1/2, working backwards, that's going to be a factor of 2x minus 1. And it's got multiplicity something even, so at least 2x minus 1 squared, and then we have something left over. So yet again, we're going to have to take f of x and divide it by 2x minus 1. Sorry, I should say we're going to divide it by 2x minus 1 squared. Okay, so let's go ahead and divide 2x minus 1 squared is this. When I expand it, I want to divide f by that. So how many times does 4x squared go into 4x to the 4th? That's just x squared times. When I multiply by all three terms, I get 4x to the 4th minus 4x cubed, and then just plus x squared. So when I subtract, actually both those terms go away, and I just have 37 minus x squared. So I'm subtracting, I should write that. So I get 36x squared, and I go ahead and pull down that minus 36x. Now I ask myself, how many times does 4x squared go into 36x squared? And that's going to go in 9 times. So when I distribute now to all three, I'm going to get 36x squared minus 36x, and I'm pulling down this plus 9. Sorry. We see that everything cancels here, and we have a remainder of 0. So our last factor in the polynomial factorization of f is this x squared plus 9. In other words, f of x equals 2x minus 1 squared times x squared plus 9. So if I want to find where the zeros are, and I set this equal to 0, I already knew that when 2x minus 1 squared equals 0, that's giving me my root at 1/2, right? So that's not new information. But also x squared plus 9 equals 0 tells us that the only other roots are at, so when x squared equals negative 9, by subtracting 9, x would have to equal plus or minus the square root of negative 9, or plus or minus 3i. So I'm getting imaginary roots, which is why when I look at the graph, I don't see anything else, right? I don't see any other roots. The only one I see is at 1/2. The other ones are imaginary. But if we are asked to find all zeros, right, that would include any complex roots. So we really need to find all of them. Okay, as you see here, you're now ready to do homework number 4 on WebAssign.